Well, a very good evening and welcome to Adson Engineering Academy. It's me, your tutor Adson, and in today's video we're going to look at a problem and pre-stressed concrete as we have discussed before. Now, in today's problem we're looking at how to draw the profile of the pre-stressing cable. Now the question says, a concrete beam with a double overhang has a middle span equivalent to 10 meters and the equal overhang on the either side of 2.5 meters. You are asked to determine the profile of the pre-stressing cable with an effective force of 250 kilonewton, which can balance a uniformly distributed load of 8 kilonewton per meter on the beam. Sketch the cable profile, marking the eccentricity of the cable at the support and at the mid span. Now let's dive in and see how then can we make this calculation. Now this is the overhang, and as you can see, this overhang is having the support here and here. As I've put them already in terms of reaction. So RA and RB is where we have the support. Then the protruding end from this support is what we call the overhang. Then on the other side is also called the overhang. Okay, so the dimension of the overhang is 2.5 meters, or the span is 2.5 meters on either side. Then the middle part of this, which is a simply supported part, if I can say, the length is 10 meters. Now if this is your UDL, the most important thing is first of all to find the moment, because from the moment is what will help us to get the eccentricity, and from the eccentricity is what will help us to draw the cable profile. Now how do you find the moment in this case? In our first thing, whatever I've done is the reaction RA plus RB, which is the upward forces, this one and this one, is equivalent to the total downward forces, which is 8. UDL is 8 times the total span where the UDL is covering, which is what? 10 plus 2.5 plus 2.5, making what? 15. So 8 times 15 is what we call the total downward forces. And then we're having total downward forces equals to 120 when you multiply this. If I take moment at point A, that means I'm standing here. Okay, so what will I get? First of all, if I stand at A, the first force that I'm considering is 10, is RB, I mean. So RB times the perpendicular distance of RB from RB to RA is 10. So that's why I'm having here 10 times RB. Okay, now I'm considering this anti-clockwise to be positive. That means the forces which will be clockwise will be considered negative. Now if this is positive and RB is done, which other force do we have? Okay, I have another force here, taking a span from this part, the whole of this UDL from this part, starting from here up to A, I'm considering it at once. Okay, starting from the extreme end here up to A, I'm considering it at once. So I have the force as I explained in my video. Please watch my video on bending moment and shear force diagram. You'll understand very well. When I have a UDL, the first thing you do is, this is the UDL value, multiply it with the total span. You will convert it to what? To the force. Okay, so the moment you do that, when you multiply 8 times 12.5, you're converting this UDL to a what? To a force. Okay, so when you convert this UDL to a force, now I have to multiply with the what? The distance, because 8 times 12.5 will act at half of what? Half of 12.5, as you can see. Okay, so this is the moment due to this what? UDL from this far end up to where A is. So the only UDL left is the UDL after this. Okay, so which is, the value is still 8.5 times the distance 2.5, the one behind A. Okay, and then times it's acting at half of what? 2.5. You get it? So that means I'm taking it positive. Why? Because if I'm standing here, this UDL will be what? this UDL will be anti-clockwise. I'm considering all the anti-clockwise forces to be what? Positive. Moment to be positive, I mean. Yes. Now, I hope you've understood this particular point I've taken. I've taken moment at A, then I've written everything clearly. So now, let's see what will be our particular value of what? Of reaction at A and reaction at B. So for the reaction at B, so when you simplify this, RB is coming to 60, RA is also coming to 60. Now let's take the moment MX. Let's get MX. Okay, so how am I taking this moment? So considering this span from here up to here, if I consider that span to be X, okay, I want to get that moment due to that distance X. I'm considering from here 0 going that side. Okay. From here up to here is the distance X that I'm considering. I have there within that I have UDL and I have RA. Okay, so understand me clearly here. If I have UDL and I have RA, now you decide. The UDL is upward, let me consider it to be positive. I mean the RA is upward, let me consider it positive. Then UDL is acting downwards, let me consider it to be what? To be negative. Okay, that is the convention I'm following. Now UDL is from here up to here, covering span X. The value of the UDL is what? 8. So convert this UDL to a force. 8 times span X. That is a force. So it is 8x. And that 8x is acting. That 8x is acting. Let's say this is a force 8x. It's acting at a half of what? Of distance X. You get it? So since it's acting at half of that distance X, so that means if I want it to be in terms of moment, because I'm taking moment from at X, so it's gonna be 8x, which is a force, times the distance from here up to here, which is what? Half of what? X. You get it? So half of X will give you the moment. So 8x times X by 2 will give you the moment. And since I'm considering downward to be negative, so it will be minus 8x and then times X by 2. That's what I've written now, minus 8 out of 2, X squared. You get it? So that's how I obtain that part. Then I have reaction RA. RA is acting upward, so I'm considering this side to be positive. Okay, so RA is 60. Then it's acting at this distance from here where I have RA up to where I have X. Mind you, the total distance here is X. Okay, and then I need the distance from here to here, but behind it from here to here is what? It's 2.5. So that means this space is total X minus 2.5. Okay, so that means that is going to be RA times this distance is X minus 2.5. I hope you have got it. Well, that's why here is plus 60 into X minus 2.5. Now that is the expression, but I need the value at a particular distance. I need a value at 2.5. Why? I need to get moment at this support. I want the value at the support. So if I substitute moment at X equals to 2.5, what am I having? So in that case, I'm having the value of the moment to be what? To be 25 kilonewton meter, because I've substituted X to be 2.5. Okay, in this particular expression. Then I also need moment at X equals to 7.5. Why? Now if you realize carefully, in between these two supports, the span from here to here is what? Is 10. Half of that is 5. So 5 plus 2.5. It means the span, the mid span of this entire beam is at 7.5. So I want the moment at that point, because I also want to get the eccentricity at that point. And just by looking at this, it's gonna be where the moment is also what? Maximum. Okay. Well, so in that case, if I substitute the value of X to be 7.5, so what am I getting here? 75 kilonewton what? Meter. So with this, you could draw easily your bending moment what? Diagram. Because what do you have? From here, you have a UDL. It's going to raise up like this. Okay? And then the same on this side. Okay? That means on this side is also going to raise, go like that. Then it's going to come down. Yes. This is going to be your bending moment diagram. of which we have found the value at this point, we have found the value at this point, then we have also found what? The maximum what? Moment. Okay, so what are the values, the corresponding values? At 7.5, 75 kilonewton meter. This is 75 kilonewton what? Meter. Then at the support, or at 2.5 from either side, the value is the same, which is 25 what? 25 kilonewton meter. So 25 kilonewton what? Meter. That was the most important steps that you had to learn so that you can clearly continue and solve this problem. Now let's have a look at what we have to proceed with. Let's now get, we have found the maximum bending moment and we want to get the eccentricity. Eccentricity is given by the formula M max divided by P. The value of the maximum moment is 75. So 75 kilonewton meter in Newton millimeter is going to be 75 times 10 raised to power 6. Divide by P. The value of P in this case is 75 times 10 raised to power what? To power 3, as you can see. Because the value is 250 kilonewton. So the value of eccentricity E is coming to 300 millimeter. So this is what we have obtained. Now let us also get the eccentricity, value of eccentricity at the support. At the support we have obtained the moment is 25 kilonewton meter. Then the expression is going to be 25 times 10 raised to power 6 to convert it to Newton millimeter. Then divided by P, which is 250 times 10 raised to power 3 in Newton. So we realize that this value of E is coming to 100 millimeter. So since we have obtained the value of eccentricity, these are the values which will help us in drawing this cable profile. Now the profile cable, just the same way your bending moment is drawn, the same way your bending moment is drawn will be the same way your value of your profile cable will be drawn. Okay, so you know the eccentricity at the support. Do you know the eccentricity? Of course, at the free end where the moment is 0, eccentricity is also 0. So you just mark it 0, 0. Okay, and then at this support you have the value of eccentricity. It's what? 100. So that means the profile of the cable, the eccentricity will be at 100. Then at the mid span, you've got the value of eccentricity 300. So that means if it's somewhere here, maybe it is 300. Then here was also at what? 100. Then 0, 0. So you join that entire point you have marked to form the cable profile. In this case, as I've told you, you have to mark it. At the support is 100. At the mid span is 300. So at this at this extreme enemy, it is what? 0. So this is what we call the cable profile that the question is asking you to draw. And I believe it was quite easy. You just needed to get the moment at the particular point that the question is asking. Then after that, you have to continue, go as far as finding the what? Finding the eccentricity. And with the values of the eccentricity, you can draw the what? Cable profile.